Hi, I'm Peter Rowlett.
And I'm Katie Steckles. And Peter, what is today's mathematical object?
Well, I've brought along a universe of cakes.
Cool.
I'd like to have a look at.
That sounds like a large object.
Yes. What I brought is it's a Lewis Carroll game. I'm a little bit confused about Lewis Carroll. I sort of author of Alice in Wonderland, right? And,
yeah.
But really called Charles Dodgson.
Yeah.
And a mathematician under that name, but a children's author under the name Lewis Carroll.
Yeah.
And then, there's a book called A Game of Logic that he wrote.
Yeah.
And then there's a book called Symbolic Logic, which is like the more detailed version of that. And they're both, in the version that I've got, by Lewis Carroll. And I'm not sure if that's a modern advertising, marketing twist, or whether it would originally have been.
Well, you'll certainly sell more books if you put Lewis Carroll on the front, I guess. But
yeah,
I get the impression that he did a lot of stuff because, Alice in Wonderland was notionally about a child that he knew called Alice.
Mm-hmm.
He did a lot of fun little puzzles and writing them little notes, and a lot of the sort of nonsense stuff that comes up in the Alice in Wonderland type books was him just trying to entertain the children around him. Yeah. I have a vague sense that there was a slightly worrying aspect to the relationship with this small child, but
you see varying accounts. Yeah, that's right.
But I think to some extent it might be that the logic book is a thing that the simplest version, I guess, is something that he could have been sharing with kids.
Yeah, that
as
makes
a sort
sense.
of fun activity. But and then maybe the other one kind of goes into more grown-up stuff.
And the version that I've got, I found online, and it turns out to be a modern reprint, and they've just made a mess of all the math symbols and stuff. So I ended up getting it from the, one of the archive.org or somebody instead, frustratingly. The other thing about Lewis Carroll is that he went to Oxford. He went to rugby school and then Oxford. And there is a book called Tom Brown's School Days, which is this written in 18-something, 1857, but it's set in the 1830s at Rugby School, and it's by someone who had been there. And I read this with my son because I'd heard someone talking about it as being like the origin of the basic story that gets used so many times, for example in Harry Potter, of the kid who goes off to boarding school and meets some friends and has adventures and this sort of thing. And I thought, that's quite nice because my son loves Harry Potter, so let's have a look at this. And I mean, it's all right, and we read it and he quite enjoyed it and stuff. There's a lot of there's a little bit of background bullying going on, and there's an awful lot of interest in sport, lots of football and so on and so forth. And I read that the author Thomas Hughes went to rugby 1834 to 1842, and Lewis Carroll went 1846 to 1849, so just sort of a few years later. And then Thomas Hughes went on to Oxford 1842 to 1845, and Lewis Carroll was 1850 to 1852. So they're almost what I'm reading is an account of Oxford and rugby as they were when...
Yeah, I guess it would be very much the same vibe as what Lewis Carroll experienced.
Yeah, you imagine so. I've sort of read that Lewis Carroll didn't much like rugby and got bullied, being a boy with a stammer and so forth, which is sad.
Yeah.
And you can certainly see that in the book. It's sort of downplayed in the novel. And then the book about Oxford I've read, I didn't read that with my son, but I thought, that'll be interesting. And just to find out what university was like in the 18th century, and there's a lot of boating and and sort of drinking and having parties and very little studying. So occasionly some,
much like uni at Oxford now,
I guess. I mean, occasionally someone takes an exam. Not much curricular detail or going to classes happening, but Anyway, so he wrote this book, The Game of Logic, I suppose is the one I'm going to start with. So my universe of cakes is basically a square divided into 4 quadrants. And these are labelled. So the top half of the square, the top 2 quadrants, are labelled X, and then the bottom 2 are labelled not X.
Yeah.
And then the left-hand column, the left 2 quadrants are labelled Y, and the right 2 are labelled not Y. And in the book, in The Game of Logic, he has it does it mostly through a universe of cakes, And then in symbolic logic, he shows how to apply it to other things. So if we take X to mean new cakes that are new,
right,
and if we take Y to mean nice cakes, which is cakes that are nice, and then what he does is he puts counters, and there's a coloured counter or a grey counter. A coloured counter means there are some in this box, and a grey counter means there are none in this box, and if there's no counter there, it means we don't know what's in this box.
Yeah, so it's kind of like a 2-circle Venn diagram, but laid out in a more helpful way. I guess, because you've sort of got like directions, and it's kind of axes, but it's not. But like you've got left or right, and you've got up or down, and they all kind of fit into a neat little square.
Yeah, definitely. It's in that area where kind of propositional logic and Venn diagrams and Euler diagrams. And do you know the difference between a Venn diagram and an Euler diagram?
I do.
One of those things.
A Venn diagram, a Venn diagram has all the possible regions that you could have given the properties. And an Euler diagram only has regions shown if they contain something.
Yes.
So you could have an Euler diagram that has, if there's no overlap between two things, those two circles don't like intersect.
They're completely separate, yeah. Or if you've got like a set A and then set B, a subset of it, then set B can be drawn in an Euler diagram entirely within set A. But in a Venn diagram, you have to draw the overlap, even though the bit that's B but not A is empty. And that's slightly weird. I think a lot of the time when people draw what they call a Venn diagram, they're often drawing an Euler diagram and don't realise it.
Yeah, you see the ones where you've got 3 circles in a line horizontally next to each other, and there's 2 overlaps, but the one on the left doesn't overlap with the one on the right. And if that's the nature of the things you're trying to describe, then fair enough, but it's still not a Venn diagram.
And because we're being observed as we're recording by members of the finite group, it's just been pointed out in the chat that this is Carroll diagrams. I think this is Carroll diagrams, which I didn't know about, but my son is in primary school and he came home talking about Carroll diagrams, which I think is what got me onto the game of logic in the first place.
Oh, wow.
But a Carroll diagram is just kind of a grid with numbers in it, basically. Anyway, so if I put a coloured counter down, that means that there are some in this box. X was new cakes and Y was nice cakes. So if I put my coloured counter in the top left quadrant, can you tell me what that means?
Well, I guess if it's top, it's X is true, and if it's left, then it's Y is true. So it's cakes that are new and nice. Yeah.
So because there's a coloured counter there, it means there are some cakes that are new and nice.
Okay, so it's like there exists kind of a propositional logic thing. There exists a cake which is new and nice.
Yes, definitely. And if I were to flip it over, it would mean there are no cakes that are new and nice.
Aww.
Yes.
You want at least one, right?
Yes.
You want one of those two things to be true.
Yes. If I move it to the opposite top right quadrant, it's now in the X but not Y section. So that is cakes.
Yeah.
It's the new cakes that are not nice, and because it's grey, that means there aren't any. So what that tells me is that there are no new cakes that are not nice. It doesn't tell me there definitely are new cakes that are nice, because the box in the top left is empty still. But were I to put a coloured counter down there, coloured counter top left, grey counter top right, that now tells me that all new cakes are nice.
Ooh, yeah, that's good. Yeah, I have a strong recollection of doing propositional logic at uni, and the lecturer that taught us used a program called Tarski's World that had the ability to generate like cylinders and cones and spheres that were different sizes and different colours, and then you could do statements like there exists a large red cone or whatever. And I've actually since seen like physical manipulatives for what are described as being for the purposes of logic that are just different sizes and shapes of physical objects. But I guess it's that thing where you kind of make a statement that is technically true, but a lot of people will interpret it as meaning something that you've not actually said. So like the statement all new cakes are nice has a kind of specific meaning, but if you say there do not exist cakes which are new but not nice, it takes a bit to sort of unravel specifically what that means and what the implications of that are. I remember our lecturer being really frustrated with the English language because there were often things that people said as sentences that were just totally not logical, like statements that you could encode logically. Or there was ambiguity in it, I guess, which frustrated him deeply.
That's definitely true, and I can see that being a frustration. Absolutely. The other thing that Carroll has is that if you know that there are some new cakes, but you don't know whether they're nice or not, that you put the token on the boundary between the two, and he calls that sitting on the fence.
Yeah, literally.
Which I think he says is a American phrase that he's heard, so he's going to use it because, of course, it's a long time ago, and these things have not spread so much.
These newfangled expressions coming over from America, right. Honestly.
Yeah.
Yeah.
Right, now, in terms of blowing your mind, we're going to go to the bigger version of the game.
Oh, my goodness.
Yeah. So, what we have here is essentially the same four quadrants. The top two are X, the bottom two are not X. The left two are Y, and the right two are not Y.
Yeah.
But there's also an inner box that takes in a bit of each of the quadrants, and inside the inner box is M, and therefore outside is not M.
Okay.
So it's like each of the quadrants is divided essentially into two, some of which is M and some of which is not M.
Yeah, and I can see how you could have like X and not Y and M, or X and not Y and not M, and that's the sort of two bits. Yeah.
Well, so he recommends X is still new cakes, Y is still nice cakes, and then M is wholesome cakes.
Oh, no one wants those.
It depends if they're nice or not.
Well, yeah.
What have I got? He suggests these two statements. Some new cakes are unwholesome, and no nice cakes are unwholesome.
Okay, so some new cakes are unwholesome. So we're in the new cakes half, which is... left.
Top.
Oh, the top.
X.
It's the X half. Okay, so it's the top half of the grid. I'm hoping that everyone listening along has already sketched this on a piece of paper, and you can just imagine, because Peter's drawn it on a piece of paper and show it to me, so I can see it. But if you haven't, then sketch it. So X is the top half, not X is the bottom. Y is the left, not Y is the right, and M is the inside bit, and not M is the outside.
Yeah, M is the middle, if you like.
So we're on nice cakes top half.
Some new cakes are unwholesome.
Sorry, some new cakes are unwholesome. So top half is new cakes.
Yep.
And we're saying that there are some in that category which are unwholesome. So would that go in the top middle?
Yeah.
Because it doesn't specify whether they're nice or not. It just says new. So it goes like that whole top outside bit. There is something in that bit.
Yes.
Yeah.
So it's not X, Y, and M, and it's not X, not Y, and M.
Yeah.
It's the versions of those that aren't M. But we don't know whether it's Y or not. So we put it on the dividing, we sit it on the fence between the two. And then the second statement was no nice cakes are unwholesome.
Okay. So we've got a grey token to indicate that there's nothing in this region.
Yep.
Nice cakes is the left-hand half.
Yep.
And unwholesome is the outside bit. So it's on the left in the middle.
Yes. So it says no nice cakes are unwholesome. So actually I can put one in the...
you can do both. Yeah.
I can put one in the old nice cakes unwholesome box and one in the new nice cakes unwholesome box. Yeah. And therefore my sitting on the fence resolves to be on the right-hand side.
Ah, yeah, because the top bit, there are some cakes in that category, but you didn't know whether it was Y or not Y, but now you've been told that there aren't any that are Y, so you must have the ones that there are must be not Y.
Yes.
Good. So what's this for then?
And then he uses it to solve propositional logic problems, basically. So he sets a bunch of exercises like this. So you'd be familiar with this sort of thing. But he gives you the statement, no monkeys are soldiers and all monkeys are mischievous. And you're to check the conclusion, some mischievous creatures are not soldiers. Yeah. So there are chains like this. There's a very famous one involving babies and crocodiles that people tend to know.
Yeah.
That's, fine, but a bit weird.
Yeah,
but anyway.
I think with a lot of these things, you just, like, I've found this trying to come up with examples for the book I've just written, where I had a little bit about logic, and it was like, you just need it to be something.
Yeah.
And, it can't be, and then I was like, I'll do a Venn diagram example. So I'll have everything that's in this circle be red and everything that's in this circle be vehicles. And then remember just how controversial the definition of a vehicle is, given that we did an entire podcast about that in one of the previous series. But I was just like, okay, so there's a red fire engine that goes in here. But, you kind of need it to be something that is sufficiently well known that everyone would be able to immediately say whether something was in that category or not.
Yeah.
And to sort of understand what the properties of that thing are. But also you don't want it to influence people too much, because if you've got crocodiles are dangerous, people will forget that it's possible to have a crocodile that's not dangerous, or you don't want it to be too strong an association with any of the properties.
Well, here he suggests if you use X for soldiers and Y for mischievous and then M for monkeys,
obviously, yes.
Why not? So the first proposition was no monkeys are soldiers. So soldiers was X and monkeys was M. So that means there's nothing in M that is also in X.
Okay.
So the top two inner areas get a grey token because there's nothing there. And then the second one was all monkeys are mischievous.
So why is monkeys? Why are monkeys?
No, M is monkeys.
M is monkeys.
Yep.
Y is mischievous.
Yep.
So all of the things that there are inside the M box will be on the Y side.
Yep. So you put a coloured one on the Y side and a grey one on the not Y side.
And you can knock out the other one because you know that all the ones that there are on that side.
Yeah, there are no monkeys that are not Y because they would be non-mischievous monkeys, and we've just been told there aren't any of them. And then the conclusion we were asked to test was some mischievous creatures are not soldiers.
Okay.
So mischievous was the Y column, and soldiers was X. So what we're being asked is if there's something within X and not Y. And there is, because we just put some monkeys there.
Yes.
So that's all right.
Yeah.
Yes.
Was there a statement about whether or not monkeys are soldiers?
No monkeys are soldiers.
Oh, okay, yeah. They're all in the bottom half.
Yeah.
Yeah, I'll take that.
Yeah.
I'll allow it.
And so basically you can do this to unscramble these things. The traditional way that you often do them is you write them as a bunch of if P then Q sort of statements and then string them together. But this is a kind of alternative way of doing that.
Yeah, and I think it's sort of nice to have multiple ways of interpreting these things, because the sort of raw logical statements for some people can be really hard to sort of piece together. Like we had a propositional logic card game called Ergo, which someone once brought to our maths jam in Manchester, and it's literally the cards have got like and not and implies, and you can construct logical statements with them, but each of the four players is a letter like A, B, C or D, and you have to try and prove that you're true and other people are false.
Okay.
So you can do things like tautology, A and not A, or A or not A implies B, means that B will necessarily be true.
Right.
But then someone else can go to that line and add in some brackets or add in a new symbol or change something. And by the end of the game, you need it to be that you're true and everyone else is false. But I found that a really nice way to sort of get my head around some of the concepts, because it's knotty, right?
Yeah,
it's a mess. And it also doesn't correspond to your natural intuition for some of these things. So having that and having, this Tarski's World, which I don't even know if it still exists anymore. It felt like it was quite an old program when we started playing with it. And having things like this, I guess, as well, will be like different ways to do the same thing. And I hope that people who are trying to learn this stuff can like try different ones and find one that helps them.
Yeah, I think that's fair. I think I found this quite hard to work through, and it helped to do a different thing. But that's because I was taught a lot of if P then Q when I was at university, I suppose. So it's like you say, it's different approaches for different people, will work differently.
Well, that's the beauty of maths, isn't it? There's always more than one way to do a thing or to explain a thing. Yeah, that's funny. One of the things it reminds me of, especially the sort of simple version where it's just two things, is when I was younger, my dad did a degree in management in his spare time, and one of the concepts that he learned about was a thing called Johari windows. Okay. Johari windows. I have no idea where the name comes from or anything, but it's this thing about management and people and identity where you have you kind of imagine it as that sort of 2x2 grid, but you're looking at it from the left and someone else is looking at it from below.
Right.
And the internal walls are kind of solid. So everything that's on the left you can see, and everything that's in the bottom half they can see. And there's sort of 4 aspects to every person. The things that you can see about yourself but that other people can't, and the things that they can see but you can't, and the things that both of you can see. And then there's a 4th quadrant in the top corner that neither of you know about.
Okay.
And it's, you know, it's like thinking about which aspects of yourself you share with people, and how you decide what you put in each of the segments. But then, like, how is there a bit that no one knows what it is? Like, that doesn't make sense.
Yeah.
But it was, you know, it was this sort of idea that people in management use to sort of understand how people interact better and that kind of thing. But it's the same kind of thing. It's like a left-hand half has one property and the right has a different, or has not that property.
Yeah.
And then the same thing top and bottom. But, you know, it's kind of like a Venn diagram, but not.
Yeah.
Right? It's just a way of representing those 4 things. That's nice. I like that. So, if you want to find out more about what Peter and I are doing, we are both members of a Patreon called The Finite Group. So if you go to patreon.com/finite group, you will get a nice feed there of all the stuff that we're up to. And if you join the group, then you can do exciting things like, for example, sit in on our podcast recordings, which some people are doing literally right now. We're both on Twitter and Mastodon. I'm at Steckles.
I'm at Peter Rowlett. We both blog at a website called aperiodical.com, which is where you can find more episodes of this podcast.
And if you have any suggestions, if you've found a vintage game written by a mathematician several decades ago and you want to let us know about it, I don't know, anything really, you can email us objects@aperiodical.com.
But especially if you want to tell us about an old game invented decades ago, that's amazing.
Yeah, absolutely. Yeah, we're into that.
The music is Funk Game Loop by Kevin MacLeod, licensed under Creative Commons. Thank you.